Hi, this is a video lesson on graphing a sine function. We're going to look at a sine function, for example, y equals 2 sine 3x plus pi over 2. If you're using the formula sheet that we provided in the class, 2 is a, and a stands for amplitude. And the 3 multiplying the x is b, and the pi over 2 is c. And when I graph these functions, I like to do two things as a way of double checking. So the first thing I'm going to do to determine where I'm going to graph, and by the way, when I ask to graph functions of this type, what I would like to see is one period starting at the phase shift. So we can use formulas to do this, or we can do a little algebra, and I'm going to do both. So starting with, I'm going to take the 3x plus pi over 2, and I'm going to trap that between the numbers 2 pi and 0. And the reason I'm using 0 to 2 pi is that is the radian interval for the unit circle. And if I was just graphing a regular sine function, so if this was just sine of x, we would have x between 0 and 2 pi. But because we're complicating things here, we're going to put the entire expression 3x plus pi over 2 between 0 and 2 pi. And then we're going to solve for x with a little algebra here. So solving for x, I'm going to first subtract pi over 2. 2 pi minus pi over 2 is 3 pi over 2. And when I take 0 and subtract pi over 2, we'll get negative pi over 2. These steps are really important, so it's a good idea to double check your arithmetic. If you know you have a little issues with fractions and such, make sure you're double checking, because otherwise it's going to throw you off. Okay, finally we divide by 3, which is equivalent to multiplying the denominator by 3. And now I could cancel those 3's, sure, but I'm going to actually leave it as 3 pi over 6. So dividing by that 3, I'm multiplying the 2. I could simplify that, but I'm going to find it easier just to leave it alone here. And dividing the other side by 3 gives us negative pi over 6. So this now is the interval for which we want to graph the function. As a double check, we're going to get this same information using the formulas. Right from our formula sheet, the formula for period is 2 pi over b. And since in this case b is 3, we would get 2 pi over 3 for our period. And that is exactly the length of this interval. If we were to subtract the endpoints, so 3 pi over 6 minus pi over 6, so subtract minus pi over 6, would give us a length. The length of that interval is 3 pi over 6 minus pi over 6, which is 4 pi over 6, which is 2 pi over 3. So see that we're getting the period either way. We can use the formula, or we could look at the length of this interval. Okay, the phase shift we can get directly from this interval. That is our phase shift. So the phase shift from our algebra work is negative pi over 6. And we could also get that using our formula. The formula for phase shift using our parameters is minus c over b. And c is pi over 2, so we're going to get negative pi over 2 divided by b, which is 3. Oh, hey, that's exactly what we wanted, negative pi over 6. So whether we use the algebra to solve this compound inequality and then read off our period and phase shift, or the formulas, we get the same result. And I do encourage you to use both, as that's a means of double checking. There's plenty of errors, places where you can make subtraction errors, silly plus minus errors, and so on. All right, now that we have our information, let's graph it. When you go to graph, we want to use some form of graph paper with either axes included, or you can draw them in with a ruler. It's a little hard on the tablet, so you're going to find my work here is not terribly neat, but we're going to do our best. I like to have the graph somewhat spread out. We don't want to do it like the size of a postage stamp. We'd like to have something that's a bit more readable. So let's see, we want to start at negative pi over 6, and I'm going to arbitrarily choose 2 blocks, 2 squares, to represent a pi over 6 distance. So 2 blocks over here, that puts pi over 6 right there. And then we're just going to count out our pi over 6's so that we have total of 4 sections. And it's okay to have these in, non-reduced fractions. Actually reads a little better in some cases. So 1, 2, 3, 4 equal sections. The amplitude is clearly 2 for this, and I'm going to choose 4 boxes for that amplitude. You don't have to use the same scale on each axis, but it is important to put at least one number on each axis so someone can tell what your scale is. Now, the normal template for our sine wave is a sine wave starts at the origin and makes one full period in 2 pi radians. So this is just a little mini graph of sine of x. And you need to know that. So for this class, you're going to need to know that the normal form of the graph for sine of x starts at the origin, goes up, then down, and does that in one rotation of the unit circle. So what we're going to do now is, now we've done all the hard work, all we have to do now is connect the dots. So I like to put the dots in actually first and then connect them. So we start at the origin, then we hit our highest point, the amplitude 2. We come back through equilibrium here. The x-axis is called the equilibrium. And then at 2 pi over 6, we're going to be down here at negative 2. I guess I could put that in here. And then back to the x-axis. Again, on the template, it's a bit hard for me to draw these. We'll see if we can at least make it somewhat decent. Okay, and then if you want to put some dashed lines or something to indicate the graph continues, that's fine. Okay, there you go. And often I'll put the name of the graph or the equation for the graph at the top here. So that's 2 sine 3x plus pi over 2. If you want to check this on a graphing calculator, so for example, a TI-84, we can do that. So this would be almost a triple check here. So we'll take our TI-84 or 83 or whatever graphing calculator you're using. If it's a TI-83 or 84, you'll have similar syntax is what I'm going to show you here. So what do we need to do? In our window, we'll need to base our graph off a function, so we'll put that in as our y1. So enter into y1 2 sine 3x plus pi over 2, and just use the pi symbol on your calculator for the pi. Go in radian mode, and then for the window we'll have our x min would be negative pi over 6. The x max would be 3 pi over 6. Y min negative 2, y max equals 2. Hit graph, and you should have exactly one period of the sine wave filling out the entire window. And if you want the tick marks to match up just as you have them, you could also put in for x scale That's the distance between tick marks. You could set that at pi/6. That's kind of optional. I don't always do that. Okay, we'll go ahead and stop there and take a look at, say, a cosine example in our next video lecture. Thanks for listening.